Can you share me his
Yep. I
his
I'm
username?
putting in Salman Subnet 24. He has his hand raised, so maybe we
Okay,
can
yeah.
see that.
Oh, here we go. Okay, he's coming up on stage.
Amazing.
Hey guys.
Yeah, we can hear you, Salman.
Let's see.
Nice.
Oh, looks like Jake is having some issues again. So shall we get started?
Yeah, let's do it.
Yeah. I mean, tell me more about your subnet. I know that this morning we had a very interesting conversation, right? I learned a lot about your subnet. Would you give us a preview as to what you're doing? And then I know that any to any is huge. It's going to be very interesting. Yeah, tell us more about what you guys are building.
Beautiful. Let me start with the inspiration for Omega, the name Omega. The inspiration of name Omega comes from Omega Point, which is this theorized future event by a French philosopher called Perry Teilhard de Chardin, where he basically predicts the point where you basically the entirety of universe spirals towards a final point of unification, and all of the consciousness and the data and sort of energy just combines into one. And like the Omega Labs is envisioned and sort of inspired by that. So yeah, basically, um, Omega Labs is an AI team that was previously at Wombo, and we are the AI brains of Wombo. After working for 3 years into building entertainment, building in the intersection of AI entertainment, like including the original Wombo app where you can take a selfie, select a song, make you sing, Dream app where you can do the art generation, and the third was Wombo Me where you can basically take a single selfie of you and it will generate like hundreds of different images of you. Um, we saw an insane demand in the mainstream audience for AI generated content. Um, and yeah, in that 3 years, we realized how much creative work is yet to be done in an abstraction below that. So we decided to found a separate research entity called Omega Labs. So we asked ourselves, what is the first, well, like we decided to ask what's like the first principle we should go about. What's the most important thing to work on? And the answer was clear. It's build the AGI. And then we were
Great
like,
answer.
okay, so what is the nature of this AGI going to be? And we hypothesized that the nature of AGI is going to be any to any, where you can take in any input and you can output any output. Um, and so then we were like, okay, so to build this any to any model, what's the first most important thing to figure out? And we quickly landed upon the highest quality multimodal dataset. We looked at the open source space and we didn't find a single source of high quality multimodal dataset.
Interesting.
Um, and I guess following that chain of first principle thinking, we were like, okay, what's the next biggest risk that the AGI will bring? And that is centralization. So we were like, okay, what are some decentralized AI and compute and like commodity creation projects? And first and foremost, we're like, we could actually go and build amongst all other decentralized AI projects was bittensor. So we're like, okay, what is the synergy here? How can we use decentralized AI project like bittensor where we can basically spin up any uh, incentive mechanism to incentivize some commodity creation to basically give us the best data set to train an any to any model. And so yeah, Omega Subnet 24 is all about um, creating the world's largest multimodal dataset. Um, and and yeah, that's what the subnet is about.
Interesting.
Impressive, right? The universe found us. So for being part of this ecosystem. I mean, you mentioned this morning that you guys had 50 million videos already streamed. Is that right? And 400K per day. That's a lot.
I think we're at 16 million now. It was 2 days back we checked 15 million. And yeah, so basically the way we have started collecting this data set is by incentivizing people to give the most novel, highest quality YouTube videos with their corresponding transcriptions, where people basically are captioning them with the state-of-the-art captioning models. And then we look at the relevance score of that caption to the video submitted, and we score the minors based on that. So yeah, we have basically 16 million unique, well-captioned videos in the dataset. And just 2 days back, we dropped a data explorer front end on top of a multimodal dataset, which I will be linking in the novelty search.
Yeah.
Yeah.
I mean, better yet, I mean, can you just like share your screen and then walk us through? Because I know it looks very impressive,
Cool.
right? So
Yeah.
I'll
Sure.
open
I'll
that chat
I'll
here.
actually yeah, I'll actually pass that to Salman, my co-founder, and let him share his screen and sort of walk us
Don't know
through
if
it.
this goes out to everybody.
Also,
But
Salman, do you want to introduce yourself?
Yeah, sure. Hey guys. So yeah, Prashant and I co-founded Omega Labs towards the start of this year,
just double check.
and before that, we worked very closely together at Wombo, basically like both ideating and then executing upon the AI side of the generative apps that we're building, and yeah, we just have had a lot of fun working together and found some pretty good, I guess, developed a pretty good relationship over that time, and here we are. All right, let me go ahead and share screen.
yep.
I feel like my YouTube is maybe broken.
All
I'm
right,
not
cool.
sure.
So here is our dataset explorer, where you can essentially go in and
Let me max
just
that.
like upload files of all sorts of different modalities.
Oh,
So
that's
first,
really
I guess
cool.
I can check out.
What's the URL?
I can put
Dev.omega
an
for
image
me.
of Bitcoin, and I'll hit search, and we have a bunch of different videos come up on Bitcoin. So you
Ooh.
can use images to search for videos,
Mhm.
That's
or
really cool,
you can
actually.
try some of the sample items. You can use, for example, an image of the beach, and now you have all these like videos of like relaxing, like beach scenes.
Hi, my name is Sonia Graff.
Yeah, well, I'm not sure if you can hear the sound of that. Probably not.
Yeah.
Yeah, we can.
I mean,
Oh,
let's try.
cool.
Let's try bittensor. Can we do that? See what
Yeah,
pops up.
why not?
Okay. Yep.
Oops.
We'll
Bittensor.
play around with that a little bit later. Very handy though. I got my friend in the mail. I don't know what is happening with my O1, but purchased one of those as well.
I see, Salman, you were doing your taxing earlier. That's cool. I
Oops.
forgot you had taxes.
No more taxes in the decentralized world. Not a fan.
Yeah. No fucking kidding, buddy. Half
Looks
the
like
reason I
some
hodl.
cool looks like some cool podcasts come up.
The future of AI, Tana protocol.
Yeah. I was wondering like if key stuff will come up because I know key stuff is one of the.
Mm,
We can
Yeah.
add Keith as a.
yeah. You can also try like audios. Here's the first few seconds of Guns N' Roses' "Sweet Child of Mine." You can drop that in the audio section, and it'll bring up a bunch of videos of guitar lessons. And then also you can also combine different modalities. So we can get some image, and then also we can
Oh
get
wow, that's
some audio.
great.
So here's an image at the beach and some audio of a dog barking. And we can search with that.
Oh, that's so cool.
And then we'll get some dogs at the beach. So yeah, that's our multimodal search explorer.
That's awesome. I love that.
Do you guys expose some sort of API?
Please.
Well, we have an API which powers this website up, and we can definitely like open that up and have that go through validator nodes.
Currently, the database is stored on the miners. Is that correct?
No, we store the data set on Hugging Face right now because we figure that that's the most like the most common place for like AI researchers to go find it. But we're exploring like instead moving to decentralized storage. So we'll be reaching out to FileTown, see if we can get it on subnet 21.
In order to make this database, you must be using a semantic embedding technique. Is that part of the Hugging Face dataset?
That's Pinecone.
So you take the dataset from Hugging Face, and then in order to create this database front end that you just showed, you had to embed all of these different modalities and then produce some sort of mapping. How did that happen? Like, what exactly is going on here when you plug into images or plug in an image and audio or something like that?
So
Sure.
the embeddings here were
Go ahead.
okay. So essentially, we're using this model called ImageBind by Meta, which can embed all sorts of different modalities into the same semantic embedding space. You guys might recall that the first of these sorts of models was Clip, which embedded text and image into the same latent space using contrastive learning, and then that sort of opened up the whole like can of worms that has grown to be the space of multimodality. And Meta, I think about a year back, they took Clip as a starting point for the text and image encoders, and then they trained some audio encoders, video encoder, and also encoders for depth maps and gyroscopes. And so we have an encoder that can like embed everything into the same latent space, and then we just we put them into Pinecone, and then when people make new requests, we embed them using ImageBind as well and find the closest vectors. And
The multimodal data set that you produce, when miners create entries in the data set, do they add an image with a description and a video all at the same time, or do they just add individual items into the data set?
They add a video, audio, and they find a video on YouTube, which comes with, like, of course, the video and the audio track corresponding to that video, and then they generate a rich caption alongside it. So video, audio, text for one YouTube video.
And this, okay, I see. This allows you to create the multimodal relationships between the items. And you have 6 million entries like this. So it's the caption from the video. You said it has the audio. Is it the title that gives you the text?
No, we don't search using the text embedding. We search using the video's own embedding.
No, but what I mean is when you create these entries, the miners create the entries. They insert the title of the video. Do they insert things like comments as well? How much do they scrape from the individual videos?
That's up to the miners, but we think that the best approach for miners to take is to actually use like vision models to see what's going on in the video and describe it. Because oftentimes like the titles and descriptions are meant to be kind of clickbaity, right? Whereas we actually want to incentivize like what's going on in the video. So,
and how do you incentivize that? How do you get them to produce a good transcript or caption for the video?
Interesting.
We judge by the image bind similarity of the embedding of the description and the video, and that embedding is maximized when the description is as descriptive of the video content as possible.
In practice, have you found that the descriptions produced by miners are pretty good? Can we go look at an example?
Yes, we can take a look at. Yes, sir. Give me a second. Let me share screen.
Generally, we have found that for many cases, long form captions are incentivized well by an image bind, but then there
Yeah,
are also many
gameable.
cases where like long form high quality captions are actually disincentivized, which point to the limitation of image bind's similarity search. And that's like the next quality upgrade that we want to make to these image bind models by either. So there are multiple ways we could go about it. We could fine tune them on like detailed captions generated by vision models. Someone, I didn't want to I guess interrupt your screen.
Yeah, let's keep on looking. Let's get some more information about Sullivan.
Yeah, actually, the
Let's
front end
create
that we
his
have.
desktop.
Yeah, so 1 sec. So, actually, I believe on the front end that we have here, it's actually just showing the YouTube description,
Yeah.
because like they're YouTube embeds. So, yeah, I can pull some up on the side and send those in the chat in a few minutes.
Surely they would be in face data set themselves, correct?
Sorry, what's that?
Would they be in the actual Hugging Face data set itself?
Yes.
Yes.
So we could go look at the Hugging Face data set right now on Hugging Face and just look at an entry. I think it sometimes it has a preview, correct?
It does, but because there's so many files in there, the preview is only for like the first 10 videos. And so that's like the first 10 videos in that were like ever submitted by miners. So that's not like the peak of like the quality.
I see. And would you expect that miners actually get better and better? I mean, I suppose they're trying to solve the image bind problem, right? It's kind of like finding an image that would go with the description, or vice versa, finding the description that would go with an image. They're attempting to effectively solve that problem by running image bind. So they have to. Do they actually have to run image bind to produce these? Do you call it image bind? Sorry, pardon me if I got that incorrect.
No, that's right. It is image bind, and yes, they are running it on their end.
And so image bind, basically, with this in this way, you're asking them to read the or watch the video and listen to the audio and then generate text. Is image bind capable of actually being a generative model as well?
No. It's purely an encoder.
It's really an encoder. So how do they maximize their score on image bind? They have to take the video and the audio and the comments and the description, and then I suppose use a machine learning model to produce a description that would be positive for image bind.
Exactly. So, go ahead.
Okay, and what are they actually doing in practice? How are they solving that problem? That's quite a difficult problem to solve, no?
So basically, there are already vision models out there like Lava, right? And Moondream, where you can generate detailed captions of a certain video. They could also use, of course, like closed source APIs, but we don't like them here. And so, or they could like
True, we don't.
take a hit on the quantity and actually handcraft them. But in practice, we have seen that like the top miners are more likely to use like vision models. But
That makes sense.
so far, we have seen that we need to actually improve our validation mechanism to incentivize to make the well first of all make it more competitive, in that they actually use the vision models. And and we are seeing that many times they can just get away by taking the title and description, because the original image bind was probably just trained on the title and descriptions
Yeah,
of
it's
the
tough to
YouTube
reproduce that
videos,
pattern.
if that makes sense.
Right, I see. So the image bind model that you're using is expecting descriptions that look like titles of videos. And so the reward model itself is not asking for much work to be done in order to get a good description. So they're converging on the way in which image bind was trained itself, being
Exactly.
yeah. And so uh, I imagine that since ImageBind was trained with YouTube videos, that you could probably look at their paper and figure out which machine learning model they used and how they used it to produce the embeddings. Sorry, the descriptions, and then you would just reverse engineer that and perform this action. So, how are you guys taking? What actions are you guys taking to ask the miners to perform even more work in creating these descriptions?
Share my
More sophisticated understandings.
I'm gonna look into this a little bit.
Yeah. So, Mr. Salman, you unmuted yourself.
Yeah. I think the answer here will come probably rather than in the form of using an embedding model. I think it'll probably come in the form of taking like rather than encoder only embedding models, taking embeddings from vision language models like Lava, as Prashant was saying. So if we can take like those more like intelligent models and use their internal representation, we think that there's a higher likelihood, and especially if we use an ensemble of models, then we can also we can try to avoid this thing you're saying of like miners just being able to, I guess, front run the data sets that were used.
It's not, in the end, it's not actually the end of the world, because you are asking the miners to do some sophisticated work here to run a fairly large language model over the images. But if you were to produce more and more captions yourself as a validation process on the validator side, where you looked at the video and produced a caption, looked at the image, produced a caption, combined those captions to produce meta caption, and then used that as the input to something like image bind. You could make it arbitrarily difficult for the miners to perform the same action, and therefore they'd have to kind of reverse engineer that new problem that you're producing. And what is the benefit of them solving this more and more complicated problem? Like the data comes out and you get better captions. Is that just going to be better data when it comes to training a particular type of model? Is that the idea?
Yeah, like the biggest shift we saw from OpenAI going from DALI 2 to DALI 3 was just detailed captioning, extreme detailed captioning. That was at the core of like DALI 3's huge leaps of improvement. And it's and even in the what was it, the Pixart 2 paper, they showed that with detailed captioning, they were able to basically just reduce the compute requirement by like 5x. Let me link that paper. And so yeah, higher the quality of and more detailed these captions, lower the amount of compute you need to actually train Sora. So the same thing was true with Sora, where they basically just copied the whole DALI 3's detailed captioning technique for their videos.
Okay, Bitlens.
And when you guys have collected enough data, and what is enough data right now, in your mind, like where are we in the world when it comes to a multimodal data set?
So here, there's this data set called intern video, which is currently the state of the art in like the like this is the go-to data set if you're training a video generative model, and it's at 25 to 30 million videos and no detailed captioning whatsoever. Pretty simple captioning, and we wanna basically beat it. And yeah.
And with projections, we'll be able to beat them in a month or less.
Yeah, so we at 16 million right now, 500K a day. That's basically, what is it, like 10 days, you have 5 million. So Yeah, I think like in a month we should beat them.
Wow. And not only will we beat them with the largest in size, but you're saying also in terms of quality.
Yes. And I think like one of the biggest questions for us, like as a subnet, is how do we showcase um like the pure quality, the high quality of this data set to AI researchers, like trainers, other labs, and how do we showcase that? And I mean, one of the answers is build like a cracked model on top of it, and the other is run multiple like image bind like similarity models to calculate genuine relevance,
Good link.
um, yeah, calculate the relevance of the text captions to the videos,
Foundation
and
models.
show
Okay,
how
yeah.
we like beat it numerically. The other could be like, yeah, like go to Philippines and like have people annotate and sort of be like, oh, which one is a better caption? Um,
We're talking about translating.
Do we need human labelers to do this process best, or is it more of a computational problem at this moment in history
I
where
think, yeah, like I think with the image vision captioners, not video, the problem, like the problem of having human annotators or recruiting human annotators right now is no more needed because images approximate videos quite well.
and because of that, it sounds like with a sophisticated language model or an image model or something like ImageBind, um, and enough processing time, like that means like taking the video and breaking it up into chunks and embedding it and then running over those embeddings and building hierarchical knowledge and getting the comments and chunking the comments up into sections and then embedding the comments and producing videos and images from the comments and then co-locating all the information. Effectively, we can build better descriptions, more and more abstract and detailed pictures of every single piece of data without even a human intervention, correct? And it's very interesting. And so I don't think anyone
So
knows the
we,
answer, but what do we think it will take to build something like Sora on bittensor with this data set? Like, are we in line with this subnet to produce the data? I don't know if you guys saw
I
that
don't
meme where
think
it's like
so.
the COO of OpenAI, and they're like, "Did you use YouTube videos?" And she's like, you know. So it sounds like they
yeah.
also use a YouTube data set to train Sora. Where are we in alignment with approaching that level of sophistication with image production? Sorry, video production.
Yeah. Salman, do you want to answer this?
Sure. So the approach that we're taking is rather than just doing like a pure like text to video model, we're going the any to any route and having Sora basically be the video decoder component of the any to any model. Personally, we think that the two parts of
Similarity.
the or
Size
sorry, I guess
number.
the two qualities that make Sora great are like one is just like it's just aesthetically pleasing, but the harder part is the fact that it shows like some semblance of like ability to be a world model simulator, and that sort of world model is already kind of present within uh, within large language models. So what we want to do is take large language models and slap like modality specific encoders and decoders onto them, and then Sora would just be the video decoder component, and therefore we would be able to train Sora like quality with much less compute because we're leveraging the existing world model that already is present in LLM.
Oh, fuck yeah.
Will the subnet be training that model?
Yep.
So this is the next plan or the next phase for the subnet is actually to train a machine learning model alongside the
No.
incentive method.
So now this is where we sort of have our doubts and like we had a crossroad basically. So what I'm thinking is basically turn this omega into a stream of live fresh data set for basically the rest of the subnets to train on. And
Interesting.
even like outside of bittensor, right? and actually commoditize the process that we have gotten started on Omega Subnet 24. And related to this, I just dropped something we have been designing on top of the Data Explorer that runs on top of Subnet 24, where we can actually monetize like this
Nice.
500K YouTube video per day creation for other AI companies. And like, okay, stepping back to answer your question, I think we should do another subnet to do any to any, which connects to the live, fresh stream of dataset coming from subnet 24 for training, training on the synthetic data, and of course testing. Because like one of the things of like training an any to any model in a decentralized sense, one of the challenges is that you don't want the miners to sort of front run the test data set and overfit to it. So how do you maintain that? By a live stream of data set. That's like yeah,
Streaming data
that's
sets.
basically scraping the web every day.
Huh.
That's really interesting. Let's dive into that value proposition a little bit more. So you guys are, by the looks of the website that you just produced or just showcased in the chat, or you messaged into the chat, you're looking to sell those 500K per day as a sort of subscription fee.
I mean, okay, so monetization is not yet strong. We are basically putting up a red painted door to validate the demand and actually see how much would people pay for it. The number we just put out there was like $15K for like 500K videos. I'm already in touch with like 3 teams from the AI grant that do want like basically unique set of data set that's not available in the open source and would love for someone else to scrape it and skip and delegate it away. And so there is some demand there. It's just that, yeah, I think it would be an iterative process of figuring out how to monetize this. Could look into Scale AI, could look into other ways of monetizing it. Also open for feedback.
You said something interesting about how the constant stream of new data is very well. It's definitely useful within inside the bittensor ecosystem itself. But do you see it as valuable, that style of data creation as valuable outside of the ecosystem?
I think so. I think so. I think like so the AI space is still catching up to what is the most important component to train these large models. And there's a lot of signal where like sort of the thought leaders in like the giga chats of people who like train large models are realizing that data is the only thing that you need to care about. And I think like as that narrative builds more out, the amateur trainers who are like spinning up their own startups would start caring much more about data, and hence the demand of this product would just skyrocket. But right now we might be early. Yeah, I guess being an AI team of a generative AI company with like 100 millions of users, I can definitely attest to the fact that like even a small high quality data set of like 100 images of a certain artist can just like and and yeah, used to fine tune like a general low quality foundational model like SDV 1.5 can just change the game. And like I can attest to that personally.
So not only could you ask for 500K videos per day, but potentially the validators can also ask for a particular type of data, right? Data about
Yeah.
Donald Trump riding a horse on a beach, and only videos of that type and that caption they would be able to, or like animation or 1950s movies or YouTube lectures or TED Talks.
Exactly. So there are 2 points here. One, prioritization of certain topics compared to the others. That's where people can come and pay in Tau to basically auction what topic should be at the top that miners are hunting. That's one point. And second
Okay,
is
this paper looks
introducing
goofy as
synthetic data
hell.
generation, where now you can
Bro.
now you can basically create a data set of like 500K videos, well, depending on what the inference speed of these synthetic data generator models that would be working on subnet 24b. But yeah, you could basically turn it into a synthetic data generation pipeline too, and that's what we
Yeah.
need for any-to-any models. And so that's one of the next big things in the roadmap after we sort of put this red painted door out.
So what would that? What do you mean by synthetic data generation? Isn't like the model that you trained to produce, that you
Yeah.
trained off the data, starts producing synthetic examples from the data set that it was trained off?
Yeah, so like we have done our thinking. Salman, do you want to take this away?
Yeah. Essentially, what you end up with is the sort of like data that these models are going to be producing isn't really like data that is like supernaturally occurring, because like mixing in all sorts of modalities just unlocks totally new use cases that don't otherwise exist. For example, like taking two audio clips and saying like the same style transfer that occurs between these two audio clips, now apply this onto an image. And so we sort of need to synthetically generate those sorts of like data pairs in order to like give the model a frame of reference for like how to generate those zero shot. And so we can sort of use fixed techniques with with expert models to generate those like multimodal like data pairs, and then we can by training an any-to-any model on lots of pairs like that, you essentially get it to be able to generate those in a zero-shot manner rather than through like narrow, fixed, specialized techniques, which would be the ones used to generate them on the data side.
Right. So if you have an any-to-any model, you don't need to produce what is it, K choose 2 models. You just have a single model that has all K to K operations in it.
Exactly.
And what are the like what's the exhaustive list of modalities that are in practice people focusing on? So obviously there's audio, video, image, text, but what else are you guys hoping to expand this into?
Brainwaves. That would be sick.
Brainwave.
Yeah, like
Hell
for
yeah.
real, I'm not kidding.
Absolutely.
That's cool. And that's for Neuralink style things.
Yeah, we already have what was that paper, Mind Video, and I think they launched an encoder inspired from Clip, and with basically this modality agnostic world model will end up within in an any-to-any. It would be extremely simple to take this encoder and synchronize it with the central world model we are training, right? Which currently is built on top of Llama 3. And once that is the case, then your Sora wouldn't just take text prompts; it would also take your brainwaves.
Brainwaves, footsteps,
I
finger
mean, at
motions.
the end of the day, like the speed at which your fingers can type this stuff is just so prohibitive to like actually
True.
to actually execute upon your creative potential that's going on in your brain. It's
So
like,
in order to get
Yeah.
to all of these modalities, you're going to have to branch out beyond just scraping YouTube. And I imagine that, two problems arise. Like, well, first of all, how do you properly scrape? And two, safety concerns. How do you blacklist data from entering the data set that's unsafe, let's say? And like, what are your thoughts on how you're going to expand this process to really go above and beyond, say, the best in the world at this type of thing?
Yeah. Yeah. So
Yeah. I think the right way to think about it is sort of a trade-off between quality and quantity. I guess essentially the more rigorous your validation mechanism, or like I guess your video, sorry, your like data quality control mechanism is, I suppose like the less throughput that you can afford, I guess like at the current moment, the highest quality and lowest throughput is to just have like a bunch of human labelers. But as you mentioned, Jake, like at some point it just becomes a question of like it's just a computational thing, right? So as the models get better, that trade-off between the quality and like throughput basically becomes less harsh. And so as long as we have algorithms that can help us like quality control the data, it's just a question of like waiting for them to become like more and more efficient.
Couple questions here, just about the validation process. So you're rewarding miners for scraping these videos and producing the multimodal descriptions. That's correct. Are they paid? Are they rewarded more for producing more data per day? Is there a linear reward system? You said that there's also a relevance sort of style reward where the miners are provided more incentive if their captions match better the image bind. Is there a weighting between those two reward systems, like quantity of videos and performance of videos? Is that correct?
There is to some degree, but we aren't strongly we aren't strongly rewarding on throughput right now. We think that we want the subnet to get to a more mature phase where once super rich descriptions have become like totally commoditized and have become the norm, that's when we want to open the floodgates towards increasing throughput. But right now we're way more focused on quality.
And
at least that's where we want to be.
That's smart. And because, I mean, there's only so much content on the world, but out on the web that you could scrape, and maybe it's not about quantity, it's more about quality. And then also it opens up some questions about, how do you know if the YouTube video is unique or just the video at all is unique? And if miners can double commit the same data, you'd have to solve those particular problems before you could get to that sort of high bandwidth solution. But supposedly you could. And other subnets that have focused on this, on just bandwidth style scraping, they've been quite successful. And you can imagine that you'll go from 500,000 per day to millions or tens of millions potentially of unique pairs being created. Hypothetically, you could also have the miners expand upon the data set itself. Like if there's 16 million items, perhaps you could reward them for expanding upon the individual entries and checking to see if those individual entries have been properly expanded upon. Did you add additional information? Did you add a different perspective on the particular entry that they were looking at?
Right.
Yeah, that's a great idea.
Wow, guys. Well, this is so go on, Salman.
Yeah, I was just saying the reason that's such a great idea is because the incentive mechanism keeps rewarding better quality captions over time, but the videos that have been submitted more early on, someone needs to go and fix those up too. So if there's new clips that are the same as old ones but much more richly labeled, that's definitely something we want to incentivize.
Mm-hmm. By the way, Jack, a question from the left field. I saw a Tau phone on Twitter. You retweeted it. I would like Tau smart glasses, which can go, which I can give to Omega miners, and then they can just go out and submit data set to us.
That would be fantastic. I'm just going to go ahead and defensively tell the crowd here that I am not endorsing that product. I don't even know if it's a complete grift. Please don't buy unless you do your own diligence and market research. I don't know the team, don't know anything about it. I just saw it on Twitter and thought, hey, cool, that would be amazing. So before you ask me to ask them to make you Tau glasses, I'm just going to go ahead and say I do not represent all of the defensive things that need to be said. because, but I really hope it is a successful product and they're actually building what they say they're building. I think that something like Humane, what Humane is doing would be fairly easy to build on bittensor, and you could have it connect into many of bittensor's subnets. And I'm sure someone is thinking about these things and working on them. So yeah, you could collect. You could have the miners wearing all of these little bittensor dongles that collect multimodal dataset entries for you, Dr. P. I'm working on it.
I love it. Yeah, I
Well,
guess
maybe you should build it yourself. What is it that, the surest way to predict the future is to create it yourself? So
yes,
Omega
connected to
wearables.
yes, I want it. Just few days back, there was this drop of egocentric, massive scale data set, which was collected across 74 worldwide locations in 9 countries, like a multi-university sort of data set project. And I mean, it's awesome. I'm thinking of like basically combining it into the Omega multimodal data set. And and I think like that is such a high signal data set for the world model. Anyway,
Sammy's up on the stage. Sammy, you're up on the stage.
What's up, guys? Can you hear me?
Yeah, we can hear you.
hello.
Sam.
Cool. I had a question for the Subnet 24 team. You guys briefly touched on this, but it was regarding monetization. So I've been thinking of a framework that could be used to categorize subnets. And just to keep it brief, the two categories that I've come up with have been subnets that are focused on being a public good, and then subnets that are focused on, you could call it like service-oriented subnets that are focused on creating monetizable opportunities for their validators. And when I was looking at Subnet 24, it seemed like this fell under the public good type of subnet, where the data that these miners were producing was being fully open sourced, which is now being done like on Hugging Face. And so you had touched, or you had mentioned on your website that like you could sell this data or somebody could pay for this data. So I'd love to hear you kind of expand on that, but also if you would consider like, the output or resource that this subnet is generating as a public good, because essentially anybody could access it. It's not just the validators that have exclusive access.
Yes. By the way, I think this is the semi I was supposed to talk to, but I kind of ghosted. My bad.
Yeah,
Am I right?
we still do need to talk.
We need to talk. Yeah.
Yeah.
So totally correct. It's for the public good. I think we can build like kind of like Discord Nitro like premium features on top of this, where like, well, one of the things that can be immediately useful to the community at large is prioritization of what topics we are going out and committing to the open source data set, right? Second could be, okay, now you can, I mean, if we could stretch this out and like have people make their requests be private and not commit to the open source. But then I don't know if this aligns with the ethos of bittensor. I guess if monetization is taken care of well and the right people are paid, then this could work. And then the next part is the teleportation of the data set, where we could monetize as well. So Hugging Face is extremely so right now we are just storing the pointers to the YouTube videos, right, in the Hugging Face dataset, and not the actual YouTube videos. But with this but with this service, we could offer the storage as well, and much better formatting for training the models.
Cool, yeah, that makes sense. Yeah, because I've just been thinking about this more with Dynamic Tau on the horizon, and with this large push that each subnet is going to have to create these revenue opportunities for their validators. And it seems like, these public good subnets might struggle a little bit because, you don't necessarily need to be a validator to actually access the resource or whatever commodity that's being produced. This could change in the future, I guess, if there was some type of if the data was encrypted and only the validators had the encryption key, and you might be able to do this on like IPFS or Filecoin or FileTau or whatever. But yeah, since Dynamic Tau really pushes for these validators to have to buy the subnet token and then find ways to monetize, it just seems like why would you become a validator on this subnet if you could just access everything the miners are producing without being a validator?
And Sammy, I agree, and I think it raises like potentials for us to think about ways that subnets themselves can be connected, because you have some of these factory subnets like 24 that they've focused on a public good, as you put it, something very valuable to be monetized by another subnet. For instance, if they produce synthetic data, or if they produce this 500,000 images, and videos per day, could be used to train another subnet on a training subnet. And it raises the question about whether or not in an environment like Dynamic Tau, or even just today, if an inter-subnet communication sort of root network could be put in place to allow demand from one subnet to trickle to another based on the determinations of the subnet owners or the participants inside that ecosystem.
I think this would be huge, adding some type of intercommunication between subnets, or even like incentives for projects to become subnets, because they get to communicate natively with other subnets, because I think this is another moat that bittensor would have. It would help prevent churn, potentially some subnets spinning off into their own digital commodity network. But more importantly, it creates an incentive for projects to want to come to this ecosystem and stay, because they do benefit from this like intercommunication network. And rather than just have, because like at the end of the day, anyone can access the resources through like a validator's API. You don't necessarily need to be a subnet, but if subnets had like priority or some other benefit, then I think that would be a big value proposition.
Another way to frame this would be, like we do have inter-subnet communication, but it'd be more like inter-subnet monetization, or the ability for there to, it's more, every subnet can communicate with every other subnet. The question is there incentive for the other subnet to communicate with the one that's calling it? And that's that's one of the problems that we think we need to solve, alongside DTAU or STAU or whatever we end up implementing. In the past, we had implemented hierarchical subnets. I don't know if you guys ever remember that part of bittensor. This is also possible. Like, we can have a multi-layered pass-through of emission, where you could have Omega here have like a secondary subnet on top of that subnet that effectively takes the some portion of the value from the original one.
Beautiful.
Guys, these are exciting ideas. Do you have any final points you want to make? And Special K and Mog Machine, if you guys want to jump in here and ask some questions, or anybody else in the crowd would like to come up here as we are rounding the end of the call.
Super exciting when it comes to monetization. I mean, the foundation is thinking about this new, very exciting project. It's called, opentensor.ai. So without giving out too much details, I will say,
these guys.
We'll make some big announcements in the upcoming weeks that will address this problem that we've been discussing.
Okay, well, hush talk.
I guess I will. I don't know.
Okay, excited.
Exactly what I want to talk about here, but
And I think Mog's been quite silent while he's listened in. Unless there's nothing from him, there doesn't seem to be any questions from the. Oh, actually, we got someone joining the call.
Oh, awesome.
We do. I wasn't sure exactly what I want to talk about, but I've been over in chat. But I guess I just liked this. I wasn't aware of this subnet, and I think that image bind is just sort of like a woefully underexplored project. Like everybody's all excited about the other like multimodal models, et cetera, and the sort of unified embedding space for those models to do retrieval over. I think has a lot of
Exactly.
there's a lot of room to iterate and make it better, and therefore a lot of room to add incentives at junctures where better could be made, essentially. So I think it's like a really like super fertile soil to be like starting off with some initial incentive structures of like creation of data sets, but I think you can go a lot farther with this. So it's very exciting. Just like thanks for doing this, guys, I guess.
Thank you.
When Sora.
True. Whenever we get together and make it, easy peasy.
Let's do it. Let's do it. We have 16 million data points, multimodal data set. And if Dr. P is right, and that's all we need, let's get something out there. Even if it's Will Smith eating spaghetti. V1.
The funny
Gotta
one.
start somewhere, right? Gotta start
One
somewhere.
part of this, right? We're gonna be way bigger than Sora, right? Because it's multimodal, not just text to image and text to video.
Can we please add into the validator code that we especially like YouTube videos of people eating spaghetti, so that when we train this model, it's going to be high quality in that domain. Just
Validator
specifically
for how good is your Will Smith eating spaghetti generation.
That's the ultimate benchmark. It's more important than MNIST now. So I think we should get ahead, win the war before the war.
Absolutely.
Great, guys. Hey, Dr. P, thank you so much for the call, and Salman, you too. Oh yeah, do you want some closing remarks here?
Yeah, I quickly want Salman to showcase like very primitive any-to-any demo, which does have video generation.
Sharing my screen, just give me a sec.
Fantastic. We got one more demo.
You guys see my front end?
Yeah.
So here we have the ability to input any of these four modalities: text, image, audio, video, or some combination of them. So you could put multiple at a time. And so the first one I'll start out with is waves crashing against the shore, and that's text to audio plus video, and it's generating these two, like the audio and the video, at the same time, and like they're interlinked and relevant to each other. Like the audio sees the video being generated, and the video sees the audio being generated in real time.
So when the audio is being generated, it's being generated with, you said, with the video. So
exactly.
So that means the audio is indeed, well, like it's going to match
to the video.
Yeah.
Yes. So like this isn't just text to audio and then text to video, like in sequence, and then you just put them together. This is audio and video being generated at the same time, and they're both attending to each other as they're being generated. So
does Sora even create audio with?
No,
It did not. It did not.
Just video.
That was the biggest surprise. All of the Sora videos were mute.
Interesting. So this is, in some sense, a step above. So, but this is not our model. We didn't train this, but this would be something that maybe the training network for you guys would focus on.
Yeah, exactly. This hasn't been trained on the data collected by subnet 24 yet. This is just a proof of concept.
But we have to do this. We have to create another subnet that uses the 500K images, videos, and text that you guys are producing to create an adversarially resistant incentive landscape and train the models to do this, right?
Yes, Paul.
exactly.
We are like 1 week away from launching the GitHub repository for that subnet.
So you're planning on launching another subnet specifically to train this model.
Yes, exactly.
Interesting.
Okay, that's really cool.
That is really cool.
Here we have the audio for the first one,
I'll just drop off here. There you go.
and this is the audio for the second one.
It's an easy thing to get audio for, I think. White noise, but it still worked.
I can also show some audio to image.
If you guys decided to make a training network on this, would it be very similar to subnet 6?
I guess there's a bunch of unique challenges for the multimodal case, but in theory, like high level, yes.
It's this kind of problem that might. Oh wow, what was the audio? Was it Aerosmith or something?
It was Sweet Child of Mine by Guns N' Roses.
Nice.
And we have some guitars coming out.
Very cool.
Interesting. Seems pretty fuzzy, but
Yeah, that's fine.
But I can't wait to see this as a secondary subnet.
Amazing.
All right, guys. Well, then, without further ado, have a good night. Thanks for coming. We'll be posting this on YouTube. I believe Mars has recorded it, and we're good. So have a good night, everyone. Thanks for coming.
Thank you. Bye-bye.
sweet. Cool. Well, I guess I'll leave it off there. Might do some coding streams later on, I suppose. But yeah, we'll wrap it up. That was very intriguing. I don't know. Yeah, it looks like the papers that I was looking at probably aren't readable, but I'll just like run them down in case anybody's actually watching real quick. So yeah, as I mentioned, so what they are using for their embeddings is image bind, if I can find it. I think I have the repo open. Yeah. So image bind is ancient in terms of this field. It's from 6 months ago from the last push. I think it's actually closer to like a year or so. So things move really fast in this field, obviously. So there have been a few iterations on the theme. The basic principle behind image bind, from what I could gather, while I was like multitasking 100 billion things at once, was that image bind is called image bind because the so like the baseline thing that all of the embeddings are trying to be converted over to, essentially, because you kind of, if you're making a multimodal embedding space, in theory, or like one of the techniques that seems fairly obvious, there might be more, but I haven't explored it too deeply, is take your input, convert it into a different modality, and then embed that. And so image bind trains a joint embedding space using only image alignment, but it works for 6 different modalities. So you could have image bind, and then you could have text bind, and then you could have audio bind, and then you could have the et cetera, et cetera. And then what you could do is, actually this would be fun. So what you could do is create from the same data set an image bind vector DB, then an audio bind vector DB, et cetera, et cetera. And then when you do your retrieval, you have your re-ranker perform the query on into each of those databases separately, and then you have your retriever do that, and then you have your re-ranker like collect the results from all of those like 6 retrievals or whatever, and then re-rank based on that. And then I think you get like a really, really robust kind of multimodal any to any pipeline, and it's extensible too. And then why token, why crypto, why Tau? Because like you can have one company with one lab that is trying to do everything all by itself, and like that's cool, especially if you're like Microsoft or OpenAI or whatever, and you have bazillion million dollars. But end of the day, you don't have like fucking, is it 6 billion, 7 billion? You don't have the entire planet worth of people willing to do your data like curation, and like the like eventually at some point you'll get bottlenecked by like you just need a sheer volume of people doing work that is like tolerable for one person to do for a while, and maybe you could pay a person to do that, but it doesn't make sense in your like business model wise. But it makes sense here to just set up an incentive and then have anybody who has time or interest come over to do however much work they want on that and then be done. So I think in terms of like, because essentially the multimodal any-to-any generation and retrieval, like the basic principle is like literally any data that exists can use it would be helpful to, for that data, build a highly curated, extremely high quality data set, and there just isn't enough hands to do that with human input in like a company or something. So you want to crowdsource it, but it's very difficult to crowdsource it appropriately with people who are like skilled and motivated, essentially, unless you're bittensor or any number of other projects. I guess technically, I don't know. There is a like a bittensor kind of fork, but not really, that I work with fairly somewhat often, called Commune AI. It's basically just bittensor, but it also has a subnet 0 where there's basically like no rules, like just do whatever the fuck you want, like set up whatever validator and validate whatever info you feel like, and that may the best man win kind of deal. But yeah, any number of protocols or programs that want to deal with data could be used for the things where like data is too voluminous to be handled by like a singular entity, and or like outside of business case, just like, you know, democratization of access, the principle of the thing kind of situation. But really quick, papers, if this is a topic that's interesting to you and or you want to do mining or validating on this network, and you're looking for market edges, start with the image bind paper and then click the connected papers button on Arxiv or Archive, or however you pronounce that. And use those tools to explore the iterations on this topic, because there have been several, and I imagine if what the validators are looking for is data of a certain quality, although that may not be the case because it sounded like what they are incentivizing towards is like a result that image bind would give you. So if you give a result that is better than image bind, then like that's disincentivized. But I imagine like the intended incentivization structure for this network is to get the highest quality any-to-any multimodal embedding at the end of the day. And it's just a matter of like they need to figure out how to set up the miners and validators to do that. So provided that that is the case, then it's interesting to start thinking about this topic if it's interesting to you as somebody who wants to run miners or do development work or try and get like market edges here. Take these papers, filter by this year, look at all of these and see how these the different techniques are working with the embedding space. That's what I did to find these. So we have language bind extending video language pre-training to end modality by language-based semantic alignment. So this is kind of what I mean by text bind. So like image bind, our thing that we're going back to at the end of the day is images. It sounds like this is the thing we're going back to at the end of the day is language. We have adapting image language pre-trained models for general video understanding. I'm not sure how relevant this is necessarily. It's just like, okay, VLMs are good at understanding videos. Yes, because videos are just a series of frames that are just images, essentially. So I'm not sure how interesting that is. Vast is interesting. This could be fun to curate the data set for, or yeah, I don't fully understand how the miner validator incentive structure works in Tau, but if I were trying to plan a like, hey, my goal is to make a really good part of the retrieval pipeline for Omni modality data, then I would want to read this paper. Separately train a vision and an audio captioner to generate vision and audio captions. Then LLM integrates. Then VAST. Video text foundational model named VAST. Okay, well, we're gonna start that one. It should be fun. This one has a silly name, so that's why I grabbed it, but also DeepMind. Multimodal processing because inputs, thus requiring very little fusion engineering. However, fully entangled throughout the network. I don't know exactly what that means. In learning, contrastive audiovisual requires independent audio and visual features to operate. Okay, so that makes sense to me. So transformers working. Okay, so transformers taking multimodal input get fed to get concatenated and fed to a single thing. So they get put together and then pushed. And that's good because we're lazy. But when we embed those, then because of that concatenation prior to the push, you can't separate them anymore. Oh God, whoops. And then if what you want to do is train some sort of machine learning model, then you need machine learning models need features to train on. Like the feature of this image is it's like orange hair, 4 legs. It doesn't really exactly translate, but like based on these features, since the like orange hair, 4 legs, has a tail, pointy ears features are missing, this image is classified as not a cat or not a tabby or whatever. But if what you're doing is processing the input and concatenating those together, it's hard to separate them back out so you can do the training on those individual features. You just kind of have to treat that like jumble of stuff that you have put together and fed to this kind of backbone as one feature because you can't separate it. So otherwise, let's see. In learning, contrastive, supervised learning requires independent audio. Okay, yeah. So contrastive learning just doesn't work. Inference evaluation of audio visual models should be possible on benchmarks having just audio or just video. Evaluation should be possible on benchmarks. Okay, because of that entanglement, it's hard to benchmark them because you need, if you're going modality A to modality B, you need an eval that measures that exact modality input. You can't have a multimodal eval, essentially, is the problem. We introduce Zora, a technique that uses masks to control how inputs from each modality are routed inside transformers, keeping some parts of the representation modality pure. Interesting. We apply this technique to 3 popular transformer-based architectures. So you can retrofit existing models with this, it sounds like, and show that with contrastive pre-training, Zora achieves state-of-the-art results on most relevant benchmarks for multimodal tasks. So when we go to evaluate after the retrofit, achieve SOTA on multimodal tasks. It does better on the evals that exist, which, as we outlined earlier, don't work on traditional multimodals as well, because the traditional multimodals require that the exact pipeline match. Furthermore, the resulting models are able to perform unimodal inference on both video and audio benchmarks such as Kinetics 400 or ESC 50. Unimodal inference. So normally, so is it because of that entanglement that normally it can't produce only video or only audio? Presumably, yes. And then presumably, like these larger models like Gemini or whatever, need to like recruit a different model if they're being asked to only produce audio or video. Or I presume that there is a somewhat any-to-any kind of SOTA right now, but there may not be. I'm not sure. I just figured, I would assume somebody has figured that out by now. Litmaps is the other tool. Omnimodal exploration through 3D insights. Anyways, these are the papers that popped up to me. You can pause this recording and look through them if any of them seem interesting to you. And then I also filtered that down to ones that have code. So all of these should have corresponding GitHub repos if you want to try any of them out. Here is that front end. It should be in the comments. I guess I'll try and put it in the description as well. This is the front end that they were playing with during the novelty search. And then, where was the actual searchy bit? Yeah. And then this, which is dev.omegatron.ai/discover, is the search, the embedding, the vector DB that they have provided. So if you want to play with any of that stuff, that is how you would do that. Also, go check out these open source AI wearables, because you definitely don't need a rabbit or a humane pin. Tab is okay, just because Avi's generally cool, but it's technically not open source. So go buy these first, and then you can look at the closed source ones, because we like open source better. Okay, I think we will call it there. If you happened to be watching this, thank you for watching it. I hope it was educational, and I'm sure